the best way to hack Microsoft could be also to use Microsoft Sign tools. We will see during this talk you will be able to do a lot of stuff with Microsoft Sign tools on Windows operating system. You will be able to get password, to manipulate memory, etc., etc. So I'm Pierre-Alexandre Bracken. Welcome everyone, and it's hack Microsoft using Microsoft Sign binaries. So I'm Belgian, living in Canada. I work at Deloitte in Canada as a senior security consultant and researcher. I have more or less 14 years experience, and I give previous talk at Black Hat Asia Arsenal. I presented this tool, Hackfest in Canada, in Washington, DC, and my next talk will be in Montreal at the NorthSec. And also I'm a StarCraft 2 player, so if you want to play with me, ping me on Twitter or send me an email, or after the talk we could discuss about that. So a lot of people actually ask me, why did you do that and how did you do that? So I wrote this talk to explain it. But the major thing is, since I was a child, I love to disassemble things, and it was not very useful, but I love that. I disassemble a dishwasher machine, etc., etc. So I wanted to know how really Windows authentication works, and I wanted to learn PowerShell and to learn about memory concepts. So the agenda is to explain what is Power Memory tools, how you can use a debugger to do all these things. We will get technical, and I will explain you exactly where to find correct bytes, which symbols to use to get password, what you can do with the memory and manipulate it. It will be useful for you. I will show you a real example. So weaponize these tools into, by example, PowerShell Empire to do real attacks. And then at the end of the talk, some mitigation. So what is Power Memory? Power Memory is a Minesweeper solver. That's all, folks. Thank you very much. It can manipulate the memory to show you how to win at this game, but it's just a proof of concept to explain, okay, we can manipulate all the bytes by just using the debugger, and the concept behind that is use PowerShell, by example, but it could be anything else, and automate all your action with it, and make some automatization with the debugger. So all eyes are on PowerShell today. Everybody talk about PowerShell. PowerShell is a very useful tool. You have some example from Carbon Black, Tanium. You have a very useful document from Symantec over here, the increased use of PowerShell in attacks, which contain a lot of very great details about use of which arguments, and it's very cool. You have last year the first PowerShell ransomware fileless one, so it's only executed into the memory. And I did invoke Tartarus, which is the same thing. So you can look on my GitHub. You will see how to do that. So just executing your ransomware into the memory. So obviously you will have the key into the memory, but to be able to reverse it, you want to get the memory when it works, when it runs. But I think it's not. There are more. There are more than just using PowerShell, because today, as everybody look at PowerShell, defenders are looking into it, and if you install PowerShell v5, you will be able to log everything. So if you make API call like virtual call log, you will be detected. And some awesome researchers like Casey Smith or Ben 10, and in the Project Empire with Armjoy, and I did also something, they show us, okay, we could use PowerShell but without PowerShell. because PowerShell is just a DLL. So you don't need to use PowerShell.exe or PowerShell-ice.exe. You can use another cool thing. You can also load PowerShell into msbuild.exe. You could look at all this technique on my GitHub and on Casey Smith's blog and on Ben 10. It's very interesting. So the concept here of Power Memory is with PowerShell and a Microsoft Sign debugger, so it's signed by Microsoft with a valid certificate, you can actually achieve whatever you want in the user land, kernel land, and Wonderland. The concept is you just send bytes to the debugger, like text, it's text, and you receive bytes, that's it. And with this concept, you can do whatever you want. So you have Power Memory, and you have the debugger. Here it's WinDBG. It's the GUI debugger of Microsoft, but in the tools I use CDB, which is the same thing, but in command line. So you can automate it. How does it work? So first, Power Memory calls the debugger, and it sends a command to execute. Secondly, he retrieves the bytes, then he parses them, and then he sends another command, and etc., etc. To read or write bytes at exact memory position. So you have a server somewhere. You have Power Memory on your computer, or I don't know where. And Power Memory asks for password, by example, okay, dump this process. So the server will give you back the dump, and you can do it remotely on a lot of servers. So you have to drop the debugger, and if you don't, you can use a debugger which is already installed if you target some Visual Studio developer, by example. But if you dropped it, yes, oh, you dropped something on the disk, antivirus will detect it. No, because it's a Microsoft Sign debugger, So antivirus will just show something totally legit. But if you want to dump something without being detected, so basically you can dump something with PowerShell directly, and you will be detected. But you can also dump something with Microsoft tools, because Microsoft did some very interesting tools to dump memory, and these tools are also digitally signed. So the same thing, you have a server somewhere, you have Power Memory, dump it, okay, here is my LSAS dump, but this time I will do it with userdump.exe. And userdump.exe is a Microsoft Sign tool with SHA-1 signatures. And in 2008, Microsoft wrote a very cool article with all the Microsoft tools you can use to dump something in the memory. So Power Memory is a userland attacker. I wrote some proof of concept that show you can get Windows password with this, from the memory with this concept. You can inject and execute the shellcode without calling API, and you can modify the memory of a process. With this concept, this awesome potential, because you have just the debugger, you send it commands, you can do it with even batch if you want, and you will be able to do a lot of things. But Power Memory is also a kernel land attacker, so with DKOM, direct kernel object manipulation. Basically, I made some other proof of concept to hide a process, by example, like a rootkit do. You can inject all privilege in the process. So basically, I will create a totally new token with system identity. You can use pass the token attack and protect the process, which is very interesting because, as Alex Ionescu showed us, it will give you the possibility to dump a process which is actually protected by protecting your process, and then you are at the same level as the other process, and you will be able to dump it. Yeah, I wrote some other stuff like Active Directory Content Attack tool, which is contained in this tool. You can do SPN scan, etc. SPN scan is very useful because if you don't want to be detected, you won't launch Nmap, by example, inside a network. So if you want to find all this, I don't know, SQL Server in the domain, you just have to query the domain controller, say, okay, give me all your SQL Server in your domain. And so it will give back to you. You can get GPP password, etc., etc. And also I wrote a tool that draws the edit topology like Active Directory topology diagrammer. You have also a different tool to bypass UAC, to provoke BSOD, which is actually very interesting because by doing this, if you are able to retrieve this BSOD, you will be able to get password from this BSOD file by feeding it to per memory. So this is the main menu. You can reveal memory password, try local escalation attempt, which is very interesting when you are in a hotel and you want to escalate your right in a computer you find in the business hall, I don't know. It will use different technique and try to escalate automatically. You can get McAfee password. It's a technique. So Jerome Nokin shows us the key used by McAfee in cyclist.xml. And the same day, me and Armjoy published a script in PowerShell, a port in PowerShell to be able to retrieve the password from these files. You can make an Active Directory assessment, scan services network, get all the tickets to be cracked by Kerberos technique, and get fun with WinMine, so to solve Minesweeper. Okay, so I told you that I used Microsoft Debugger. So I will show you basic thing about the debugger, and you will be able to understand the technical part after that. So Jeffrey Snover, which created PowerShell, which was Monad, say us, okay, automate all the things. So I decided to automate the debugger to get password from memory to hack Microsoft. But why using the Microsoft debugger? Because it's signed. You know, it's signed with a certificate from Microsoft. So it is trusted, you know? Sorry. Okay, it's trusted everywhere, which is very interesting because it will force Defender to look for behavior and not just for signature or you know, by example, when you lock PowerShell activities, you will be able to look for a lot of strings which is used by actual and current PowerShell tools. Like if you use invoke Mimikat, by example, in the logs, you will have a lot of very interesting things for the defenders. Here, you won't have that. You will see some bytes which are sent. So the first step is, okay, well, how to use that? So you can type db to display bytes, and you will have bytes like that. You can use dw to display 2 bytes, dd to display 4 bytes. Display if you want to look inside a memory position and to look the Unicode character, you can do du at an address in the memory. And I did that in a portion of the memory which contains my email. So you will see directly great information. If you do that on a portion of memory which contains a password, you will have some non-understandable characters because you have to decrypt it. So it's not just du blah 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 and it works. Yes, if you want to do that, the first thing you have to do is to load the symbols. If you don't do that, you will try dd and some symbols. Symbols, and you will have a lot of quotation mark, which means that, okay, I don't know where this symbol is in the memory. So you load the symbols, you repeat the same thing, and you will have your bytes. What is symbols? When you compile a program, you will generate a PDB file for your program, and you can, do a lot of things. Microsoft do the same things and publish on one of some servers all the symbols for all the tools and operating system. And CDB or WinDBG, which is the Microsoft debugger, is very cool because it will load correct symbols for your dump. Okay. So symbols are free. You can just take it with the debugger. So maybe if you are in the blue team, you want to look for this get things HTTP request because it's maybe not normal, or it's normal because if you have developers, they will use it. So to get password, you will need several symbols depending of your operating system. So the password in the memory are contained into a list entry. And so it's a double circular list entry, and each element is linked together in a nice loop. So you have to, if you have, if you have like 5 users connected, you have to go through each element to get all the credential information. And so this list is contained at this symbols address, which is llogsslist. So you will type db llogsslist. For the key on NT5 operating system, you will have the DSX key, and you will be able to get the key which encodes your password and the feedback. For the key on NT6 and NT10, it's H3 key and AES key, and the initialization vector. But we need to go deeper. So we will get technical, and after that you will be able to understand exactly where are the bytes to steal to be able to reverse the password. So it's in the user land, obviously, and the provider, the authentication provider that we will attack, it's a Dajos security support provider. Why? Because so yes, it's implemented for LDAP protocol, but also for web authentication. And when your user in a corporate environment use SharePoint, by example, they will need it. So for every SSO single sign-on application, they will use it. So it's a very interesting provider, and it is actually very simple to reverse. So if you want more information, I put the link of the Digest security support provider. So it's really used everywhere. And Microsoft made some improvements. So before, if you log off completely, your information stayed into the memory. But now when you log off, it doesn't stay in memory. So you want to get a password. Okay, so you have to steal very specific bytes. And you have different possibilities to do that. You can simply dump the LSAS process, and you can do it locally or remotely. You can convert a neighbor file.sys to dump file, and then you give it to per memory. You can provoke a BSOD, but it will be maybe detected. And yes, you can do it by leveraging the hypervisor, like Hyper-V or VMware. I will show you that thing is very interesting. Also, if you have kernel access, you can access directly the LSAS process without dumping anything. Yes, I say hypervisor. So you are an Hyper-V operator or a VMware operator, and you are not still domain admin. Seriously? Imagine you have absolutely no right in Windows operator, so some DC domain controller in the domain. So you have absolutely no right. you are just a Microsoft Hyper-V operator or VMware operator that can dump a virtual machine. So yes, if you want to do that on, by example, Hyper-V, you can use livekd. I don't know if you can see that. So livekd.exe, which is a tools created by Mark Rusinovich from Microsoft, which wrote a lot of great sysinternal tools. So you will put livekd.exe, some parameters on the DC, by example, where you have absolutely no write. You have the dump, you feed it into per memory, and you get the password. So it could be a problem. But for Microsoft, it's not a security problem because you are behind a computer which have access. So it's not a security problem. It works for containers too, because when you launch containers into the memory into a host, you will have a new LSAS process created, and you have all the access on the host machine. So the same thing, and you will get the password. So can you see the password? Because he is, yes, over there. Can you see it? It's the same thing, where's Waldo, But I told you that I will show you how to get it. So I will show you precisely. So it's a Windows 2008 R2 dump of LSAS process. But per memory works from 2003 to 2016 and from XP to 10. So obviously the bytes are not exactly at the same place, but the concept is the same for all these operating systems. So it's a linked list, double circular linked list. So the first information over there is the next entry in the linked list. This one is a previous entry in the linked list. This one is this address, the current address. It's a LUID. LUID is a 64-bit that is value that is guaranteed to be unique until the next reboot, and on the system you are. It's guaranteed only until the system is restarted, but not very interesting to get password. It's a username address, so you can type DU and this address, and you will have the username, NetBIOS, and the encrypted password in red. So if you type DU, you won't get nothing interesting, just an encrypted thing. The domain name address, DU, blah, 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 and you have the domain name address in clear text. The username and domain address, max length and min length of the field, which is interesting, obviously, if you want to automate the thing. It's not enough. You have all the information, but you have an encrypted password. So you want to use some other symbols like DD, and then LSASRV exclamation point and the symbols. You will have the presentation on the Black Hat website after the talk, so you will be able to retrieve it. So if you type that, you will get this block of memory. You will type the next address, DD, and that's the address. You will have some, okay, so the size is in red. I think it is the size because I did a lot of empirical approach, so I think it's the size. In yellow, you have the tag KSSM. It's always the same thing, so it's good reference. And then same thing, so tag MSS key. And in pink, it's the key you look for. And if you type just, because it's very useful for the AES algorithm after that, if you type DB, you will have the key in the good format, which is little endian. So you have the key, you have the information, the password encrypted. It's not enough. You need the initialization vector. So yes, it's very complicated. You type B and the correct symbols, and you get it immediately. So with all this information, in a very simple algorithm, you will be able to get the password in clear text. I will show you that in a demo. Okay, so I'm on a 2016 server. So it's a menu, reveal password. Okay, do you want to use Active Directory commandlet? If you do that, it will try to match the user you found with an actual user in the domain and will get the right of the user. But if you don't want to be detected, you are not it's not mandatory, you know. So you can say, no, I want to get password locally. It was a fun thing if you want to exfiltrate data to pastebin, but it's not something you want to do every time. And do you want to clear event log? So it will just replace, you know, the event log with you by stopping different thing and elevate himself, etc. And then, okay, getting valuable informations. And you get the password, which is password 3, because password 3 is more secure than password 1. It's over there. And all these weird characters is a computer key, which is not a password. But it's contained into the same linked list. Thanks. So with the same concept in userland, you can inject a shellcode in a remote process and execute it. But I don't want to use Microsoft API. So to launch normally the process, you have to, you know, use several API call, and I don't want to use it. I just want to use the same concept, so sending bytes and receiving bytes. So you need different information. You want a memory executable zone, a null padding zone in the memory to inject your shellcode in, and the address. If you have all this information, you can run your application, your malicious one or not malicious. So to do that, you need to parse the PE dynamically into in the memory. You will get the address. So I will make different steps to be able to do that. So the first thing you have will be the address of the module loaded to inject. After that, you will get the PE header address that you will find in the MS-DOS header. So I give you where it is. I wrote a white paper which will be published also on the website of Black Hat. So you will have more details on the different operation, and the code is also on the internet. From the PE header, which is 24 bytes, you will get the size of the optional headers in bytes, and from this optional header, the section, blah blah blah, etc. And from the section table, the virtual size, virtual address, and raw data pointer. And with all this information, after injected your code into the null padding zone, you will just send this call to the debugger, which is, in fact, saying, okay, the next instruction, because it's a registering instruction pointer, will be this module address. And bam, you will get your calculator. Yeah, in this example, it's calculator, but it could be also different things. So I will show you a demo, sorry. Okay, so in power memory, you have power process. Okay, I will launch a notepad.exe. It's not me. So you can inject shellcode in process. You give your process name, which is in this case .exe. Okay, so and you have it. So if you want to see where it is contained, It's Process Explorer from Marcus Sinovich 2, okay, Notepad, and you have your calculator here. So it works. Thanks. So let's continue with that. Now in kernel land, which is pretty cool, if you want to do things in the kernel land, you will have to start with something. Microsoft put into all the operating system a tool called bcdedit.exe, and by using this tool, you can say, okay, next time you reboot, you will reboot in debug mode. So by using that, you can do a lot of things with the debugger. Obviously, you can protect that by using different techniques, which is well known. But personally, I didn't see a lot of company protecting that. So you can try it. It's interesting. So we will hide the process. And it's not a new technique, but the way we will did it, so using a PowerShell automating the debugger, it's pretty new. So to be able to hide a process from the e-processed list, you want to do that. So we break all the link of this process, which is your process you want to hide. And then, yes, maybe we cannot see very well, but you will say to the debugger, okay, now I want that you do that. Okay. And then the same thing, I want that you do that. So the processes are well linked. But it's not enough. If you just do that, you will experiment like 3 seconds later, BSOD, a crash. So you want to make also this thing, link this process to itself and this thing. So I automated that with PowerShell and the debugger. I will show you that. So I take the same thing. Oh, sorry. Okay. So I launch Notepad. I like Notepad. You saw, can you see Notepad? Okay, over there. And I want to hide it. So in process, you have different things. And if you want to hide a process, you say, okay, hide me, please. Hide me. I want that you hide this process. So you saw, okay, found the, okay, it just disappeared by using this technique. And if you want to unhide, I wrote the unhide part 2. You need this address because, okay. You saw, did you saw kd.exe? Okay, and Notepad is here again. So it works with the same concept. So you can do a lot of things because it's a rootkit, you know. Okay. Okay, now you want sorry, you want a real case, and to show that you could do some real red team or real case, I made a pull request for PowerShell Empire, but as you know, they had a lot of things happened with ATD lastly, so they did not integrate yet. So Empire is a PowerShell framework that you can use to do some red team activities, and it will basically launch an agent with PowerShell and give you the possibility to do all what you need to accomplish your red team or your attack. And so yes, they said, okay, you we don't necessarily use PowerShell.exe, but if you try to automate with the 1.6 version of Empire, if you try to obfuscate your activity with MS Build, by example. So with MS Build, which is another Microsoft tool, you can load an XML file which contains a C# code and launch your agent into the MS Build. So you won't see PowerShell.exe, but with the Empire framework, when you will launch another attack through your agent, it will launch another PowerShell process. So you will see again the PowerShell process. So the pull request is 298, and to be able to do that, the first thing you have to do is, by example, be fishy and explain to the user you have to click on that thing, I don't know. Then the target loads the Empire agent, and through it, you load per memory into the target machine memory, so it will run into the memory. You drop the sign debugger, or use an existing one. If you target correctly, you can find different debuggers that you can use too. Then you make fun and profits. And 6, you go to jail. So I have a demo for that. So okay, you are here. Oh, sorry. Okay, so we have no agent. So be fishy. I think I have something to just show you. Okay, it's not on this computer. Okay, I'll show you that. So I launch another server. Normally on DC1, I have something to. Okay, it's not there. I don't know why. Documents. Okay, sorry about that. But I did some, video in case it does not work. So password 3, yeah. Okay, so here it's just a basic launcher. So I have my agent. So you want get credentials. The tools is called RWMCRS, and the info that you need to get is just the agent, which is already the case. So you can type run. Okay, so I don't know why it does not work now, but okay, I did that. Sorry. So you type run. And normally, okay, yes, it was not. You will get something like that. Sorry, it's not the GIF. So basically, it will drop your debugger, and it will send some bytes, and you will get all different passwords like that. So it's pretty cool because here it's a domain administrator. Okay. So mitigation. Yes. As I said, the big difference between this kind of technique and technique like directly using PowerShell or another dropper, because a lot of security people say, okay, I will inject something into the memory directly, and it's completely fileless, or I will inject something into the memory and hide it into the memory, but every time you need to have a file. You know, you send an email, or you send something which will drop something, or you put a thing on the disk, and then this thing is not malicious, but it will say to the malicious thing, okay, do that, do this, do that, and will call some different APIs that in Blue Team you will see. So here, the idea is, okay, just put something which is trusted, and then automated it with bytes. So if you are in the Blue Team, you have to look for behavior. You know, signature is not, it's not enough in this case. You have to look for dumping activities, and I wrote services, which is cool, which can look for LSAS dumping and which process did it. I don't understand why Microsoft didn't do that, because LSAS, normally you don't have to dump it, you know, for normal activities. Look also for suspicious bcdedit.exe uses, because normally, you know, I don't know, if you are an accountant, you won't use that. Don't trust the endpoint defense mechanisms. So you have some great new tools like I don't know, Tanium, Silence, Carbon Black, etc. But it's not enough. You really have to look for and hunt for suspicious behavior. And yes, look for suspicious user tools behavior. So at Deloitte, we do a lot of things. And basically, the thing is to say, okay, it's not a matter of if, but it's a matter of when you will be attacked. So you have to protect, you have to know where is your crown jewels, where is your very important information. You want to proactively assess your risk. You will build a multi-layer defense, fortify your organization, and prepare yourself for the inevitable. So the takeaways of this talk are, okay, basic SIEM, so you know what is a SIEM. It's something you used to automate different hunting activities like hunting, automate logs, parses, and look for suspicious things. But in this case, it will be not enough. So basic SIEM use case today with a correct version of PowerShell can detect your invoke mimikatz loading into the memory, by example. Because it will use a lot of things which is very suspicious, like .NET download string. Everybody knows that, and if you use that, we will take a look at that. Use public symbols to get memory address. Microsoft gave you the possibility to know all the information of the operating system and application. Take it, it's free. You can play in user LAN and in kernel LAN with this technique. And the last thing, look at the pull request to know how it was implemented and to be able to do the same thing. And before completing the talk, I will show you something which is pretty cool. Sorry. Okay, I'm sorry. Okay. In the famous game, so I have a Minesweeper solver, and I want to be able to win because I love to win. But I never played to this game before that. And you have a lot of things. You can flag the bombs like in the normal game. You can demine the bombs. You can reveal the bombs, explode the bombs. You have a 42 option, and you can clean the board. If I try option 6, clean the board, by example. Okay, so memory detect, okay, it's a 30 times 16 board. So I will refresh. And okay, it just removed all the bombs. So now I click. Yeah, I won. That's cool. Oh, okay. Oh, I just changed. Sorry. Thank you very much for attending this talk. It was a pleasure for me. If you want to ping me, it's my Twitter and my GitHub, where you will find a lot of interesting other things. Thank you very much. Okay. Okay, so the question is, what is the difference between red and blue team? So the red team basically is a team, that will try to offensively attack an organization to prove, some flaws or weakness into the organization. So it's something we do at Deloitte, and the concept is, okay, nobody into the organization will know that we do that. Only one person. Okay, so all the other team, the security team, won't know that, and so we will act like a real attacker. We don't want to make a pen test. So the goal is not to test all the possibilities in the weakness of the organization, but only to get in. And easier, it's better. And blue team is a defense part. So it's exactly the same, but in the other part, So the question is the red team is authorized to do that? Yes, we are authorized because it's a client, but with strict restrictions. So you don't want to affect the production or things like that. So not DDoS things or certain things like that. Yeah.
So in one of your demos, when you were launching the farm memory,
yeah,
you were already logged in as an administrator, right?
Yeah. So yeah.
Is that are you already logged? If you're not logged in as an administrator, then will you have any issues with the permissions, the farm memory and concept?
So if I understand correctly, you asked am I an administrator on the target computer?
Yeah.
Yeah, I am, and that's why I wrote the auto-escalation things. But yes, the concept is you have to be an administrator or just have the debug right. So you can be a normal user without administrative right, but having the debug right, you will be able to do that. Or if you are just a VMware operator, you don't have to be anything on the target machine.
So basically you're saying if I'm logged in as a normal user and I'm able to download the debugger, then I will automatically have administrative rights through the debugger?
So the question is, if I'm a normal user, can I just download the debugger? No, you have to get some specific rights. So you have to be administrator or have debug right. But if you are a normal user and in addition you are not administrator on VMware but operator, and you have the right to make some file operation and downloading file operation, you will be able to get the password without having any right in the computer, the target computer. Yeah.
When you talked about hacking process.
Yeah. Yeah.
You said that if you just fix your forward network links, you'll get a visit.
Yeah.
I'm not sure why I get that.
Yeah, because it's, I don't remember exactly, but I think it was critical architecture error or something like that. Actually, it's because the kernel will check again, okay, this structure, which is a eProcess structure, is not linked to anything. It's not normal like crash, because in normal operation it will be the same. It say basically that the operating system is corrupted because it's not normal that eProcess structure is not linked to anything else. Yeah.
Can you do the demonstration of executing shellcode?
Yeah.
PE injection?
Yeah.
Am I right thinking that you still have the two caveats, i.e., firstly, you won't be able to pass the command line argument onto because you're injecting the PE shellcode, and secondly, you can't have, for example, a two-stage payload because of the limitation of of the shellcode's execution, and will be able to call modules and load it into.
Okay. So if I understand correctly, you said that when I try to inject something and execute it in a remote process, I need to first inject with the parameters and arguments.
Can you in the example, you load it at the count?
Okay, yeah. No, the only thing I did was the first thing is you have to pass dynamically, so the in-memory process. So you have to get the base module object and then all the thing. The first thing is that by just sending, bytes. So you will see only bytes. And then you receive other bytes. And you need to write other bytes, which is actually, in this case, a calculator, so calc.exe information. And then to be able to launch it, you will just say to the RIP register, which is a register instruction pointer, for the processor, you will say, okay, next time you will launch this address. That's all that I did. So I didn't call any API. Obviously the API will be called by the debugger, but you won't do it with your executable or your script or anything you use to do that. Yeah. Yeah, I look for that. I didn't publish that because it's not something. But actually, I didn't show you that for the system things, I retrieve empirically the system hash, which is currently exactly the same on all machine and operating system. So if you get that, you will be able to be system on any computer. But no, I didn't get the NTLM hashes, but I get it into the registry, but not in the memory for the proof of concept. But yes, you could do that too. And you could also attack other provider, authentication provider. Here I just attacked the digest one, but you can attack other provider too. Yeah.
So what's the main difference between using this method and say just dumping the memory through the task manager and then parsing that offline with VPCats?
Yeah, you can do also that. So it's exactly the same thing, but it will be difficult to dump remotely. Remotely you won't be able to do that. So here I automated also remotely. So if you are in a 10,000 computers domain, you can do that for all the computers too. Yeah. And the goal was to show, how can we do that through all the different possibilities and like, Hyper-V and VMware things too, which is the same concept again and again, and manipulate, memory, writing it to the memory with the same concept. And so just with the debugger. So now I assume that if you are in a blue team, you want to look after this kind of behavior. Yeah. So, sorry, I didn't.
Do you need debug mode to hide the process?
So the question is, do you need debug mode to hide process?
Yes.
Yeah, because it's in the kernel mode, so you need it. So for all kernel things you could imagine, decom, etc., you need debug mode. Debug mode, BCD edit, etc. Okay. Yeah. Any other question? No? Okay, thank you very much. Bye.